Hello students, welcome to the video lecture 8 of the chapter Magnetism and Matter. Today's topic to be discussed are Curies Law, Ferromagnetism. Curies Law statement: the magnetization of a paramagnetic material is inversely proportional to absolute temperature T. We also know that magnetization of a paramagnetic material is directly proportional to magnetic field strength at that place where the material is placed. So combining these two, we can write mathematical equations as, from the second statement we can write magnetization is directly proportional to B naught, let it be equation 1, and magnetization is inversely proportional to capital T, equation 2. If we club these two equations, we get M is equal to C into B naught by T. Here C is taken as proportionality constant, and we shall write this equation as equation number 3. Moving ahead, we know that capital M is equal to chi h. Magnetization is equal to susceptibility into magnetic intensity, and B naught is equal to mu naught h. Substituting these two values in equation 3, that is this one, we get a equation chi h is equal to C mu naught h divided by T. Therefore chi will be equal to C mu naught divided by T. So here C is Curies constant. This is called Curies law. Next, let us study ferromagnetic materials now. So materials which exhibit ferromagnetism are called ferromagnetic materials. Let us define them. Ferromagnetic substances are those which get strongly magnetized in an external magnetic field. So these are the materials which strongly get attracted to the magnets, and they move from weaker to the stronger region of magnetic field. So example for ferromagnetic substances are iron, cobalt, nickel, and alnico. Further, let us try to understand what exactly happens in ferromagnetic substances. In case of ferromagnetic substances, the individual atoms which have dipole moment, like paramagnetic materials, will try to interact with a large number of individual atoms and form a domain. So here the moment is over a macroscopic volume, not a individual atom, and they try to align themselves and form a domain, and the domain has a common direction of dipole moment, as we can see here. So here we see that there are domains formed. So this is one domain, another domain, and so on. So all of them are oriented in random direction. So each domain has their net magnetization. So in the absence of external field, the domains are randomly oriented. The result in that one domain cancel out the effect of other. So that's why we have net magnetic moment will be 0. So if magnetic field is absent, then we have their orientation to be like this. And what happens if magnetic field is applied on them? Then once the magnetic field is applied in certain orientation, then the domains get oriented along the direction of magnetic field and they get magnetized. So let us now try to study properties of ferromagnetic substances. First property, ferromagnetic substance is strongly attracted by the magnets because they respond in terms of domains for the applied magnetic field, so they get rapidly attracted towards it and strongly attracted towards it. So they move from weaker region to the stronger region of magnetic field. When ferromagnetic substance is placed in magnetic field, the magnetic field line will tend to crowd into the substance because they try to highly get magnetized in the direction of magnetic field. So as we can see here in this case, so they were randomly oriented, suddenly magnetic field is applied, all of them will get aligned in the direction of magnetic field. So in the presence of external magnetic field, ferromagnetic materials get strongly magnetized in the direction of applied field. Fourth property is the value of chi is big and positive. So chi is much greater than 1. Since we know mu r is equal to 1 plus chi, therefore ferromagnetic substance will obviously have mu r much greater than 1. So chi has to be big and positive. So the value of mu r is also high, as we said it. Mu r value is high. Reason for that is the magnetic field lines will tend to pass through it rather than passing out of the material. So huge magnetic field lines will be crowded into the material, so that ferromagnetic material should have mu r much greater than 1. Since we know that mu r is equal to mu by mu naught, thus mu will be much greater than mu naught. That means the magnetic field lines are passing through the material as compared to the air beside it. Ferromagnetic substance shows all the properties of paramagnetic substances, but in a very much higher degree. So conclusion is we are going to compare them on this basis. Here you can see the table which compares the diamagnetic, paramagnetic and ferromagnetic substances based on the chi value in each case. We can also compare them in the case of relative permeability as seen here, and we can also try to compare them on the basis of permeability. So differences of these materials are very important. We can also note that. Thank you students, and see you in the next video lecture.